In this last example of fractions in context, we're going to look at the operator model. So what do we mean by operator? So you can think of operations like addition, subtraction, multiplication, or division. We're using a fraction to operate or transform some quantity into another quantity. And we're going to use the example of an exchange rate. So there are lots of exchange rates you could think. If you went to another country, say Europe, you would bring in your dollars and you would exchange them for euros. So we're going to look at the same type of idea and first figure out how we would do an exchange, and then figure out the fraction that the exchange would require. So let's read the question and highlight important information. A machine at an arcade gives 3 tokens for every 4 quarters you put in the machine. And here's our question. How many tokens would you receive for 12 quarters? We're asked to draw a picture to show the exchange. Okay? So lots of times drawing a picture is very helpful for making sense of the problem. You could actually imagine yourself at the arcade and you have quarters and they're round. And how about for tokens, we use triangles because they both begin with T, and that will help us remember. So here's a picture. You have 12 quarters. And you're standing at the machine, and you know that for every 4 quarters, you will get 3 tokens. So 3 tokens for every 4 quarters. And notice that for every, that's a good indicator of a fractional relationship. So you may say, I will put in these 4 quarters, and the machine will give me 3 tokens. Then you could put in your next 4 quarters. You'll receive 3 more tokens. And your last group of 4 quarters will give you 3 more tokens. So the answer to this question is, how many tokens would you receive for 12 quarters? Well, notice you'd get 3, 6, 9 tokens. So you will receive 9 tokens. And now here we're asked, what fraction of tokens to quarters will the exchange require? So this is the part where we're going to represent this as a fraction. So think about how we did this. So we took our amount of quarters, so we used 12 quarters, but we could use any amount of quarters, and we divided them into groups of size 4. So divide the quarters into groups of 4. And we had 3 groups of 4. Then for every group of 4, we receive 3 tokens. So we could think of multiplying each one group of 4 by 3. So then we multiplied by 3. So how can we think of this as a fraction? Well, if you're going to look at a fraction, you can think of the top number as the multiplier, and the bottom number as the divider. Okay. So we took this and we divided it into 4 groups. So we divided the 12 by 4 to get 3. And then we multiplied each of those 3 groups by 3, the number of tokens we received, to get 9. So this fraction, okay, is the operator fraction, or the exchange fraction, to change tokens into quarters. And notice, or change quarters into tokens, excuse me. 3 tokens to 4 quarters. Okay? So we will write 3 over 4 is our exchange factor. Okay. So notice whatever you're starting with is what you want to divide by. So when we were starting with quarters, we wanted to divide by quarters to eliminate the quarters. We just had the 3 groups. And the top number is what you want to end up with, in this case tokens. So if we were to start with tokens and we wanted to change them back into quarters, we would actually reverse this relationship. It would be 4 quarters per 3 tokens. So here it's 3 tokens to 4 quarters. Okay. Or we could say 4 quarters to 3 tokens. So notice they're both representing the same relationship, but the order tells us which way we're exchanging. Okay, so if we want to change to tokens, the tokens goes on top. If we wanted to change from tokens to quarters, the quarters would go on top.